All right, this is worksheet 3, multi-step calculations, and I hope I can write small enough to do these because these take up a little bit of space. So be sure when you're writing yours, write small, write neat, keep everything in line, and it'll make it very, very simple. So first thing I'm going to do is identify my knowns and unknowns. I've got how many formula units of sodium nitrate will react with 20.0 grams of calcium carbonate to produce sodium carbonate and calcium nitrate according to the following reaction. So, known is 20.0 grams of CaCO3. My unknown is how many formula units. Well, hopefully by now you know if we're using formula units, we're going to be using Avogadro's number to count how many formula units are in there. So we're going to be using 6.02 times 10 to the 23rd in somewhere in our calculation. So my chemical equation looks balanced, so I can go ahead and get started. I'm going to take my known, and I'm going to write it way over here to the side. Put it over 1 just so it lines up with everything else. Grams of calcium carbonate are on the top, so I'm going to need grams of calcium carbonate on the bottom. Gram stands for grab your periodic table, and when I do, I find that the weight of, again, I've already done these calculations. So when I calculated the weight of a mole of calcium carbonate, I got 100.909 grams per mole. So I'm going to take that number and put it right here. Remember, I've already calculated that. You'd need to calculate that for yourself. And that's in 1 mole of calcium carbonate. If I have 1 mole of calcium carbonate on the top, I'm going to need to have 1 mole of calcium carbonate on the bottom, or at least moles of calcium carbonate. In this case, I go up here and I find there's calcium carbonate, and I really do have 1 mole of calcium carbonate. Now, remember I'm going back here and it's formula units, and notice how I didn't write completely in the formula units. Formula units of what? Well, the formula units are of sodium nitrate. So I'm going to add that back in because now I need to be sure that I'm going to come up here and I'm going to get my how many moles of sodium nitrate are in my formula, or rather in my equation. So the ratio is 2 moles of sodium nitrate per 1 mole of calcium carbonate. Remember, I have to go to formula units, so I need 1 mole of sodium nitrate has 6.02 times 10 to the 23rd formula units. Now I've got formula units here, so I'm just going to double check and see if I'm ready to do my calculations. I've got grams of calcium carbonate, grams of calcium carbonate, mole of calcium carbonate, mole of calcium carbonate, mole of sodium nitrate, mole of sodium nitrate. I'm left with formula units of sodium nitrate. So I'm ready to calculate that. I put it in my calculator and I get 2.41 times 10 to the 23rd formula units of sodium nitrate. And that is my final answer. I'm going to double check to make sure. Let's see, I need 3 significant figures. I've got 3 significant figures, so I'm all set. Let's try this. How many liters of nitrogen gas are needed to react with 90.0 grams of potassium at STP in order to produce potassium nitride according to the following reaction? Well, if it's telling me that there's an STP and we've got nitrogen gas, that means I'm going to need to do liters, which is volume. So I'm going to be using that 22.4 liters in 1 mole. So let me start with my known. got 90.0 grams of potassium. My unknown is going to be how many liters of nitrogen gas. And I look at my chemical equation, and it's N2. Now, start with my known. I'm going to start way over here at the side because this is probably going to be long. Always start over on the side as far as you can, and then you won't run out of room generally. So if I got grams of potassium on the top, I'm going to need grams of potassium on the bottom, and I'll need to grab my periodic table to find that 39.10 grams of potassium are in 1 mole of potassium right off my periodic table. I've got 1 mole of potassium on the top, so I'm going to go up to my reaction. There are 6 moles of potassium, and I'm going to go back over here and I'm looking for my nitrogen per 1 mole of nitrogen gas. I've got 1 mole of nitrogen gas on the top, so I'm going to need to have moles of nitrogen gas on the bottom. I'm working toward liters, so I know that since I'm dealing with a gas, I have 1 mole of nitrogen gas will be 22.4 liters of nitrogen. Let's check things out. I'm to liters, so I think I'm done. I'm going to double check. Grams potassium, mole of potassium, mole of potassium, mole of nitrogen, mole of nitrogen. I'm left with 22.4 liters of nitrogen, and that's what I need. Put it in my calculator, and I get 8.59 liters of nitrogen gas. And that is my final answer. All right, here's number 5, and right off the bat I see I need to balance this chemical reaction before I can even do anything else. So I'm going to get started here, and I'm going to do the tally method. So I'm looking in my reactant side. I've got carbon, I've got hydrogen, and I've got oxygen. I have 3 carbon, 8 hydrogen, and 2 oxygen. On the product side, I have 2 hydrogen, 3 oxygen, and 1 carbon. So I'm going to start with carbon, and I'm going to go over here, and I'm going to try 3. If I have 3 here, that means I've got 3 carbon now. 3 times 2, and I've got 6 oxygen, plus 1. Let's go ahead and just update that total. I've got 7 oxygen on that side. Now I'm going to deal with my hydrogen. I've got 8 on one side and 2 on the other. So if I multiply this by 4, and update my totals, now I've got 8 hydrogen, and I've got 6 over here times 4. For my oxygen, I've got 10. Still not balanced. But I look over here and I see that I've got O2. If this is 5, update my total, now I have 10, and everything's balanced. So I'm going to erase this so I have a little bit more room to work and do this problem. My known is I've got 15.2 liters of oxygen. My unknown is how many liters of propane, which is C3H8. So I'm going to start with my known, 15.2 liters of oxygen over 1. Got liters of oxygen on the top, so I'm going to need to have a conversion factor with liters, and that's going to be 22.4 liters of oxygen are in 1 mole of oxygen. If I've got 1 mole of oxygen on the top, I need to have moles of oxygen on the bottom. Go up to my reaction, I see that there are 5 moles of oxygen in my balanced chemical reaction. 5 moles of oxygen, I need to get to right there, the propane. So I'm going to find propane in my formula, and I have 1 mole of propane. Now I'm ready for my next conversion factor, mole of propane on the top, so I need to have mole of propane on the bottom. 1 mole of propane. Now I'm getting to liters. So 1 mole of propane, which is a gas, is going to be 22.4 liters of propane. And that looks pretty good. I'm going to double check my units. Liters of oxygen are canceling off. Mole of oxygen, mole of oxygen. Mole of propane, mole of propane. I'm left with liters of propane, which is what I need. I'm ready to put that in my calculator, and the answer should be 3.04 liters of propane.